Okay, so today we're going to be talking about factors, multiples, greatest common factors, and least common multiples. First off, we're going to go over what a common factor is. A common factor is factors that two or more different whole numbers share. So for example, if you look at the numbers 8 and 24, and we listed out their factors, they have 1, 2, 4, and 8 in common. So the greatest common factor is the greatest whole number that is a factor of two or more numbers. So in this example up here, although they have 1, 2, 4, and 8 in common, the greatest number there is 8. So the GCF, or the greatest common factor for 8 and 24, would be 8. Let's try one together. So let's find the greatest common factor of 12 and 18. We're going to start by listing these factor pairs to help ensure that we have all the factors and we don't miss any. So first we're going to start with 12. We're going to list the factors starting with our lowest number 1, and its pair is 12. Next we're going to move on to 2, and 2 times what equals 12? 6. And then we're going to go to 3. 3 times 4 equals 12. So now we have all the factors for 12, and we're going to move on to listing out our factors for 18. So I'm going to start with 1, and then 1 times 18 equals 18. And then I'm going to move on to 2, and 2 times 9 equals 18. And then I'm going to move on to 3, and 3 times 6 equals 18. Now between 3 and 6 I have 4 and 5, so I'm going to ask myself, can 4 times anything equal 18? And it can't. And then can 5 times anything equal 18? And it can't. So I now know that I have all the factors. So let's go back over the directions. It says circle all the factors that appear on both lists. So now I need to look for the factors that appear on both of my lists. So I see they have a 1 in common. So I'm going to circle both of the 1s. They also have a 2 in common. So I'm going to circle both of my 2s. They have a 3 in common. They do not have a 12 in common. They do have a 6 in common right here and here, but no 4 in common. So now the next set of directions says I'm going to place a triangle around the greatest of these common factors, or the largest of these common factors. So looking at 1, 2, 3, and 6, what is the largest number? 6. So 6 would be my GCF of 12 and 18. Okay, let's try another one. So you can also use lists to help you. So for this one we're going to do all the numbers that 12 and 32 have in common. Okay, so you're going to start by listing out the factors of 24 and 32. Go ahead and pause the video until you have all of those listed out. Good, so you should have gotten the following for your list of factors. 24 would have been 1, 2, 3, 4, 6, 8, 12, and 24. And 32 would have been 1, 2, 4, 8, 16, and 32. So we can follow what we did in the last problem, and we can circle all the numbers they have in common. They have a 1 in common. They have a 2 in common. They do not have a 3 in common, but they have a 4 in common. Do they have a 6? No. An 8? Yes. Not a 12 or a 24, 16 or 32. Good. So after that, what you want to do is you want to find the largest of those numbers. So looking at this list, I can see that 8 is the largest common factor. So 8 would be my GCF. Good, let's try another one. So looking at 14 and 21, go ahead and pause the video and start by listing out your factors of 14 and 21. Okay, so you should have gotten the following list of numbers. The factors of 14 are 1, 2, 7, and 14. And the factors of 21 are 1, 3, 7, and 21. So you're going to start by circling the factors they have in common. They both have a 1 in common. They both have a 7 in common, and that is it. So what is the largest number they both have in common? The answer is 7. So your GCF of 14 and 21 would be 7. So next we're going to talk about multiples. We've been talking about factors for the past 2 days, and now we're going to be talking about multiples. So a multiple is the product of the number and any non-zero number. So let's look at an example. 3 times 2 equals 6. 3 and 2 are both factors of 6, and 6 would be your multiple. So I like to think of these as your math facts. So when I'm listing multiples for a number, I start by doing my multiplication math facts. A common multiple is a number that is a multiple of 2 or more numbers. So for example, starting with 3, my multiples of 3, I'm going to count by 3, would be 3, 6, 9, 12, 15, 18, 21, 24. This could keep going on for infinity. My multiples of 6 would be 6, 12, 18, 24, and I could keep going, 30, 36. So for this, I'm trying to figure out which ones they have in common. So looking at the multiples 3 and 6, I see they have a 6 in common. I see they have a 12 in common, a 24, and if I kept going, they'd even have more in common. So we're going to use this to find the least common multiple, so our list will not be going on for forever. So finding the least common multiple of two numbers. Let's start by just listing out the multiples. So why don't you go ahead and pause the video, and you're going to try to list out your multiples of 12 and 18. Remember, you're counting by 12s or doing 12 times 1, 12 times 2, etc. Okay, go ahead and pause. Okay, so if I listed out the first 10 multiples of 12, I would have gotten the following: 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132. Now this isn't all the multiples of 12, it's just the first 10 multiples of 12. So we're going to do the same thing for the first 10 multiples of 18. Go ahead and pause the video and list out the first 10 multiples of 18. Okay, so the first 10 multiples of 18 are 18, 36, 54, 72, 90, 108, 126, 144, 162, and 180. So the next thing I want to do is I want to figure out what multiples they have in common. So I'm going to circle the multiples that I see they have in common, and I'm going to look for the smallest one they have in common. So do they have a 12 in common? No. 24? No. 36? Perfect. So since I went from least to greatest, I know that 36 is the least common multiple. That means it's the smallest multiple that they have in common. Although they have other, you can see they have 72 in common, but 36 is the least common multiple. So you can try these two on your own. Go ahead and pause the video. Okay, so if you listed out the multiples for 9 and 12, you would have realized that the least common multiple for 9 and 12 is 36. Also, if you listed out the multiples for 12 and 18, you would have found out fairly quickly that the least common multiple is 36 as well. Next, we're going to be talking about finding GCF using your factor trees. Now, I know this may be a little blurry for you to see, and we are going to be going over this in class, but I will explain what we're doing as we go. So, you're going to start with a factor tree for your two numbers. So, looking at 30 and 50, I'm going to break down 30 into 2 and 15. Since 15 is a composite number, I'm going to break it down again. And I break it down to 3 and 5. Next, I'm going to make my factor tree for 50. So I start by breaking it down 2 and 25, and then 5 and 5. So now I need to write out the numbers that they have in common. So they both had 1, 2 in common. So I'm going to place that here in the middle of my Venn diagram. And they also had 1, 5 in common. So I'm going to place that also in the middle of my Venn diagram. Now the numbers that they did not have in common was a 5 over here, since I used this 5 for my center, and then this 3. So with these factors that they have in common, I'm going to multiply those out. 2 times 5, which will give me 10. So the greatest common factor of 30 and 50 is 10. So let's try this with 30 and 45. I start with my factor trees for both number. I break down 30 into 2 and 15. And then since 15 is composite, I'm going to break it down into 3 and 5. Next, I go over to 45, and I break it into 3 and 15. And then 15 is composite, so I need to break it down again into 3 and 5. So I'm going to find the numbers that they have in common. So they have 1 3 in common, which I will place in the center of my Venn diagram. And they have 1 5 in common. So the 3 they had in common and the 5 right here. So next, this 2 is a factor of 30 but does not have anything in common with 45. And this 3 is not in common. So I then take these two numbers, 3 times 5, and I get 15. So the GCF, or the greatest common factor, of 30 and 45 is 15. So there's two different ways you can find the GCF. You can either use your factor tree to help you with the Venn diagram, or you can use lists. List is easy when you have a smaller number, and using this Venn diagram is great when you have two larger numbers. Okay, so the last thing we're going to do is we are going to factor out the greatest common factor of both of these numbers, 12 and 18, to use a distributive property. So what is a common factor of 12 and 18? So the greatest common factor of 12 and 18 would be 6. So I'm going to say 12 divided by 6 is 2, and then 18 divided by 6 is 3. So I can factor out this number 6, and I'll get the same answer. 12 plus 18 is 30. And if I use my order of operations, 2 plus 3 is 5. So 6 times 5 also equals 30. Okay, go ahead and pause the video and try this one on your own for 42 and 14. So, when you look at 42 and 14, if you need to, you can list out your factors and find the GCF. The greatest common factor of 42 and 14, it is actually 14. So when I do 42 divided by 14, I get 3. So I take out the greatest common factor. 42 divided by 14 is 3. And then I do 14 divided by 14, and I get 1. So I can write it like this. I should get the same answer. When I do 42 plus 14, I get 56. And then when I use my order of operations, 3 plus 1 equals 4. And then I do 14 times 4, and I get 56. So that is one way you can use a GCF to help you with the distributive property, which will be very beneficial as you go into 7th and 8th grade.